Okay, good morning, everyone. Welcome to this TIPS Development Dialogue that's looking at um, a focus on technological change within South Africa's manufacturing sector. I'm Saul Levine from TIPS, and I'm standing in for Nokwanda. I'm not Nokwanda, you may have noticed, who was supposed to chair the session. She was unfortunately unable to join us and has asked me to step in. We're going to have three presentations in the session, and then we are going to have a discussant, Dr. Sean Cunningham, and then we'll open it up for questions and discussions to people in the room and online. So welcome to everyone. We've got the three presenters are in the room, and we've got Danae Govender, who's going to be talking about the electrical equipment industry, Lutando Zondi, who's going to talk about the electronics industry, and Lucas Mtembu, who's going to talk about technological change in the clothing and textile industries. So we've got interesting presentations that are lined up. What we have done with these papers is that they've linked to a broad set of industry papers, as well as papers that are looking at international trade in the sectors or industries, and papers that have looked at climate change and sustainability issues in these sectors. So we've already had one workshop where we've looked at the sustainability and climate related issues for sectors. And this is our second workshop in the series. And we'll have a third one that takes a different focus or with an industry context. What we have done is papers on, I think, 7 or 8 of the industries. And so we're only having 3 presented today on different industries, but the rest are available on our website. So if people want to go into our website, I think there was a small technical issue this morning, but it should be up and running shortly. But people want to go into our website, they can look at the papers from the overview papers on each of those industries, as well as the papers looking at sustainable development, technological change, and international trade. So a lot of useful information on each of these sectors. So we encourage people to download and view these papers and enjoy the discussion and thinking about technological change in different ways that are impacting industry. It's something that TIPS has been looking at for a while. We've got a specific page on our website or portal on our website that covers a whole range of issues around technological change. And Sean Cunningham, who's our discussant for today, has been driving much of that work. So there's several papers, blogs, and technological change profiles, as well as some case studies that we've done looking at technological change in specific companies. So quite a robust amount of information thinking through these issues. The question then is, why are we looking at these issues? And for us, a key part of industrial policy is the role that technological change plays in driving industrial development. And that's important because if we staying still, we're falling behind. So we see it at a company level, and we see it at an industry-wide level, and we see it at a country level. So without getting to grips with the much needed technological change that needs to happen, we fall behind. So it's an important area of work for TIPS, and we've done a lot of thinking and research on this topic. And these industry studies fall into that broad categorization. And there's many ways, and there's a lot of work that we're still doing in trying to strengthen our thinking around how do we link industry to the change that needs to happen, and support companies with technological change. These studies form part of it, so that we enhance our understanding and approach to that. So let me then move on to our first speaker. And I'm going to ask Danae, who's first on the list. I don't know if that's the order that you expect it to go in, but I'm just going to go in the order that's on the list. It's I don't know if it was done alphabetically because then Lucas would be before Lutanda. So, but Danae is first up, so invite Danae to come through and present.
Sure. Good morning, everybody. As introduced, I'm Danae, and I'll be talking about technological changes in the electrical equipment industry. So in terms of the outline for this presentation, I'll be just taking you through a brief overview of the industry. We'll then unpack some of the emerging technologies and the drivers of technological change. We'll then assess the technological changes that are occurring in the electrical equipment industry, and then uncover some trends in South Africa. And finally, we'll conclude the presentation. So in terms of the industry overview, the products that are included in the electrical equipment slash electrical machinery manufacturing subsector are insulated wire and cables, electric motors, generators and transformers, electricity distribution and control apparatus, accumulators, primary cells and primary batteries, and finally electric lamps and lighting. And with regard to the economics of the industry in 2024, it contributed 2% to manufacturing gross value added, around 4% to manufacturing employment, but in the same year, South Africa did run a negative trade balance in electrical machinery of approximately 58 billion rand. So regarding the emerging technologies, we've got about 5 or 6 here, which include the Internet of Things, artificial intelligence, digital twins, augmented reality and virtual reality, and additive manufacturing. So in industrial settings, Internet of Things, or IoT, refers to a network of interconnected devices that collect, analyze, and transmit data through sensors, communication devices, and computers. And what this does is enable remote monitoring and predictive maintenance. AI combines computer science and data from equipment and processes to mimic human intelligence in decision-making, learning, and problem-solving. And in industrial context, this enhances operational and cost efficiency, advances innovation, and improves quality. Digital twins are a virtual representation of a physical object or process. And it's basically generated using data collected from sensors connected to the real world or the physical world, effectively creating a virtual model of equipment for simulation and testing. Augmented reality and virtual reality, closely related but not quite the same thing, creates either a partially immersive or fully immersive environment that allows users to interact with digital objects as though they are real. And in industrial context, this improves training, accuracy, and safety. Additive manufacturing is a process of producing objects by adding material layer by layer based on a digital design. And the benefits of this is that you can produce components or parts with less waste, and there are fewer emissions associated with production as manufacturing can take place closer to customers. So, apologies. Regarding the drivers of change, outside of advancements in digitalization, efficiency and sustainability objectives are key drivers of technological change. Businesses and utilities are increasingly turning to digital solutions that leverage data analytics and remote monitoring and control to reduce downtime and optimize the performance of assets. Rapid population growth, particularly in developing countries, has fueled the need for efficient and sustainable infrastructure solutions. Simultaneously, the need to upgrade existing electricity infrastructure in many regions has intensified, as traditional systems often fail to meet modern efficiency and environmental standards. Similarly, global climate change commitments have led to a rise in the installation of renewable energy technology, which relies on advanced components for optimal integration into existing energy systems. And finally, increased consumer awareness of environmental impacts and growing demand for smarter, greener technologies have prompted businesses and governments to respond. So regarding the technological changes applied to the electrical equipment industry, IoT for electric motors, for example, use sensors to gather and analyze data related to motor vibration, speed, and temperature to identify potential failures or malfunctions before they occur. It also facilitates remote control of electric motors, enabling remote adjustments to operational parameters. Just before I go any further, just to note that this is not an exhaustive list of the applications of emerging technologies to electrical equipment. It's just a selection, as different technologies can be applied in different instances. So in the design of electric motors, AI algorithms can analyze extensive data sets of electrical components and design rules and produce optimized designs more efficiently than manual methods. It also enables virtual prototyping, where engineers can simulate electrical systems and test designs in a digital environment, eliminating the need for costly physical prototypes. Digital twin technology for electrical transformers can simulate temperature behavior, overload capacities, and insulation aging, with operators being able to access the information digitally. It also provides visualization tools to support decision-making when evaluating equipment. So AR rather can be used for electrical wiring. This allows technicians to view interactive 3D models of, for example, aircraft and its components overlaid on the real world assembly line. And this allows them to follow precise instructions, view wiring schematics, and ensure that parts are installed correctly. And this is done in some cases using a sort of AR headset or similar device. Additive manufacturing for lamps and lighting use fewer materials, can incorporate recyclable products, and results in fewer carbon emissions as products can be produced locally, reducing transport emissions. And fittings and fixtures can also be customized depending on preferences. In terms of the application of emerging technologies in electrical utilities, the Dubai Electricity and Water Authority has deployed some of these emerging technologies and more to enhance service delivery and customer satisfaction. Regarding trends in South Africa, and another disclaimer, the companies mentioned in this section were just the companies that came up during the research. And so I've presented them here. In terms of IoT for electric motors, we've got the WEG motor scan solution, which allows for the monitoring of information related to radial and axial vibrations, motor temperature, and operating time. Users can also access and analyze the data that's stored on the platform directly on their mobile devices, or they can explore it in greater detail on the WEG IoT platform. And it also supports the configuration of maintenance alerts. Hitachi Energy has a digital twin solution for high voltage direct current systems and power quality applications, which consolidates asset information analytics and operational data into a user-friendly, customizable dashboard, which also features interactive 3D visualizations of assets and offers access to related plant and equipment details. Becker Schrader has an augmented reality digital application that allows users to interact with their products remotely. It enables users to visualize their products and lighting poles in real-world environments, both indoors and outdoors, using augmented reality, basically on their cell phone. Users can toggle product lighting and compare optics and photometry to, decide which product would best fit their needs. In terms of IoT in utilities, an example is seen in the electrification of the Upper Blinkwater village of the Eastern Cape. Here, the system comprises a solar PV, a diesel backup, and a battery energy storage system, as well as the Siemens SICAM microgrid controller, which controls the energy source and ensures the efficient use of electricity. With the system, households in the Upper Blinkwater village have at least enough electricity for a cell phone charger, a kettle, as well as a TV and satellite dish. And similar systems are deployed in water meters and household solar installations, allowing users to track consumption and save on resources. So in terms of the enabling environment, South Africa has a number of initiatives supporting technological change and sustainable innovation. Policy instruments include the 12L energy efficiency allowance that allows qualifying taxpayers to claim a deduction for energy efficiency savings resulting from activities adopted in operations. Regarding finance, the IDC's Machinery, Equipment, and Electronics Strategic Business Unit funds digital and energy innovations, while the Energy SBU supports microgrid development, among other things. Regarding research and development, the CSIR's Living Energy Lab explores approaches to the energy transition, which includes microgrid as well as AI solutions. In higher education, in addition to offering courses that equip students with advanced digital skills, the University of Pretoria's Hatfield Digital Twin City seeks to establish a smart grid to monitor electricity usage across the precinct, helping the municipality to allocate electricity based on energy requirements, while UKZN Smart Grid Research Centre, in collaboration with ESCOM, is dedicated to research and training on integrating renewable energy through modeling, simulation, and real-time analysis. Now, while these initiatives exist, several barriers do remain. Education and training systems, particularly outside of higher education and particularly outside of the urban areas, are not fully preparing the workforce for technological change. Poor digital infrastructure, again, particularly outside the urban areas, also limit adoption. In addition, automation may exacerbate the unemployment issue as jobs that entail repetitive tasks may be replaced, with other challenges also including the high upfront costs associated with adoption and cybersecurity risks. So in conclusion, the electrical equipment industry is evidently undergoing a notable digital transformation driven by the technologies mentioned in this presentation. And these technologies clearly enhance efficiency, innovation, and sustainability, but their uptake in South Africa remains limited. Industrial innovation is led by foreign entities operating in the country. And if we were to build competitiveness in this industry, it would require continued and enhanced collaboration, investment, and skills development. Thank you.
Thanks, Danae. Danae, sorry, I should have mentioned Danae, Lutando, and Lucas are all economists at TIPS, and Sean is an independent consultant who works with us. One of the key issues I think Danae raises, and it's something that we may want to unpack, is the efficiency gains we get through technology, but in the context of mass unemployment. But the need, as I said earlier, in industrial policy to always move ahead with technological change. So these very contradictory forces that are often at play when we're thinking about technological change. I think that's an important discussion that we may want to dip into in the question and discussion time. I'm now going to move to Lutando. And what we will do is we'll have questions and discussion at the end of the three presentations. It probably makes it flow a bit better. So if you do have questions, you can post them now on the chat or make a note, and then we can get to that shortly. Lutando, over to you.
Thank you. Good morning, everyone. So my name is Lutando Lezozondi, and I'll be presenting technological changes in the electronics industry. Okay, just a brief outline of the presentation. I'll just briefly introduce the industry and then move on to the overview, which entails value chain analysis, economic contribution and employment. And then afterwards, we look into global technological changes in the industry, followed by technological trends and innovations in South Africa. And then the last slide will conclude. So basically, the electronics industry consists of two segments. That is the manufacturing side of it, which entails the designing and producing of electronic components and devices, and the information and communication technology side of it then applies these systems to process, store, and transmit information. So, for example, there would be the software side of it, software production. And we've seen that the industry has revolved the industry has evolved rapidly over the few years, where we've seen that devices are becoming much smaller and faster and more energy efficient. So just a brief, sort of a high-level picture of the industry value chain. At the core of it, we see that as inputs, we have core minerals such as silicon, copper, and the others, which are then essential materials that are used for manufacturing electronic components such as semiconductors, integrated circuits, resistors, and the others. So, and then when you move on at the final assembly stage, okay, so sorry, I just forgot to mention that South Africa does not really is not involved at the sub-assembly level where the production of electronic components are done. Basically, most of it is imported. And so when you move on at the final assembly stage, that's where we see a lot of South African firms that, for example, assemble printed circuit boards, which are then used as components of products such as decoders and smartphones and the remotes that you have and computers and the others. And so at the distribution stage, and then the components are also supplied to other sub-industries such as the automotive, capital goods, medical devices, and other telecommunication equipment. And so so then they are then distributed to local markets, or they are either exported, or they're also produced for medical device manufacturers. And then at the post-sales services stage, we see that it also involves software updates or hardware recycling. So moving on to the economic contribution of the industry at the domestic level. The industry remains a small contributor to the economy. And what we have seen on the studies that we have done is that the share of GDP has declined it declined from 0.29%, for example, in 2004 to 0.18% in 2024. And what we also found was that the professional equipment, which then includes medical devices, was sort of the major sub-industry that contributes to GDP, of which it was at 0.11% in 2024. Looking at the employment trends in the industry, similarly to the economic contribution, the industry employs a small workforce, where we've seen that with the medical appliances and instruments, which also includes medical devices, as a major employer within the electronics industry. So we found that on average, it employed around 9,000 workers between 2010 and 2023. So now when you focus on the global technological changes in the industry, the research that we conducted, we found that at the global level, electronics manufacturers are adopting technologies that are in advanced packaging, which entails integrating multiple semiconductor chips, making them much smaller, faster, and energy efficient. So these technologies include the wafer level packaging, like the fan-out or flip chips, as well as the more advanced packaging technologies such as the 2.5D stacking and the 3D stacking. So these technologies are actually applied at a sub-assembly stage where the production of electronic components are done, of which in South Africa is quite limited. So moving on to the electronics assembly, we found that the technologies that are used at the electronics assembly level, of which I mentioned earlier on, that South Africa mainly operates at that stage, we found that the technologies that are used involve the component mounting technologies, such as the surface mount technology. So these machines, what they do is that The components are mounted directly on the printed circuit board, which is the PCB surface, and we found that they're actually lightweight and more energy efficient. The other technologies that are used at the assembly level include the through-hole technology, as well as the hybrid assembly, which then combines the surface mount technology and the through-hole. So when you look at the technological trends and innovations in South Africa, we've seen that particularly in the printed circuit board assembly, the technologies that the local firms are using include the surface mount technology and the through-hole technology. For example, within the research, we found that Microtronics Manufacturing and Expander Works, they invest heavily in high capacity and advanced pick and place machines, as well as other manufacturers also invest in pick and place machines, the solder paste jet printers and reflow ovens. At the in the ICT sector, we've seen that firms, for example, Foresight Holdings, they use AI to either develop new products or services that entails predictive analytics and personalized consumer experiences. We found that also with other innovations so the Product Development Technology Station, which is located at the Central University of Technology, what they do is that they've used advanced computer numerical control, which is the CNC machines, they use it for post-processing additive manufactured components. So the CNC technologies are relevant in the industry because they play a huge role in terms of manufacturing the printed circuit boards or in the assembly of electronic devices. Other innovations, I've listed them on the broader technological change paper that is also available on the website. So basically, to conclude, just to summarize all the key takeaways of what we've seen in technological changes in the industry, that although the industry is a small contributor to the economy and employment, we've seen that at the global level, the manufacturers are applying technological innovation, which is driven by emerging technologies such as advanced packaging and AI integration, of which I've mentioned earlier on. Where in the South African context, we've seen that the manufacturers are also applying technological trends, but however, they are not at the sub-assembly level, but they're rather at the final assembly where, for example, printed circuit boards are assembled. And overall, I found that, or rather, then going forward, I, sort of advise that it's important for the industry or the government to focus on skills development, environmental sustainability, and policies which are essential to unlock the full potential of emerging technologies, which then will involve partnership between government, industry, and academia in order to further drive innovation and productivity and market expansion in the industry. Thank you very much.
Thanks very much. I think that gives us a useful overview of what's happening in the electronics industry, and I think we can have some more discussion when we get to that space on the agenda. Let me now call Lucas, who's going to talk to us about clothing and textiles. Thanks.
Okay, good day, colleagues. I'll be presenting technological changes in the clothing and textile industries. I suggest that you have a look on the website on this paper. I worked on it with Ritabule Mulala. Okay, so the outline of the presentation was, I'll start with an industry overview. I'll look at the history of technological change within the clothing and textile industries. I'll look at emerging technologies. I'll look at some of the drivers of technological change within the clothing and textile industries. I'll look at technological change within the value chain, and I'll look at technological trends in South Africa. There will be a specific case study. And I'll conclude with some of the key takeaways from the presentation. Okay, so the overview of the industry. So the clothing and textile industries contribute about 2.7% to manufacturing gross value added. And clothing and textiles, leather and footwear as a whole contributes about 3.9%, and this was in 2024. Clothing and textile industries employed over 200,000 people in Q2 2025, and CTFL as a whole employed nearly 206,000 people. South Africa is a net importer of clothing and textiles, with imports coming from Asia, and that is mainly China. And some of the major export partners, some African countries, as well as the EU and the USA. So some of the export that went to the USA were exported through AGOA, but at the same time, South African firms weren't able to fully utilize AGOA because of rules of origin limitations. The clothing and textile value chain is buyer-driven and is mainly led by retailers. The industries are supported through the RCTFL master plan, and they were previously supported through IPEBs, and some of those programs have been continued with the master plan. Okay, so some of the history of the clothing and textile industries. Tech change in the 1800s was driven by modernization, with shift to manual and hand-based production processes to spinning and weaving. In the 1940s in South Africa, textile mills advanced by moving to steam power. And in the 1970s, industries started using sophisticated machinery and automated processes. Despite significant technological change by some South African firms, other firms still confront limitations that limit them from adapting to new technologies. So for that reason, some parts of the value chain are less efficient and they are using outdated technologies. So some companies are hesitant to adapt to these technologies, such as harvesting machinery because of textile production processes, including cutting, picking, which is the case. So the issue there is the issue of quality, and they are not adapting to those new technologies because they don't want to hinder the quality of the cotton that is being picked. So some of the emerging technologies are automation. So that is automation of production processes, and there's been increasing use of sewing bots. This improves precision, lead times, and replaces skilled workers. But there are different jobs that are created in other parts of the value chain. So with automation replacing some of these manufacturing jobs, in the other parts of the value chain, jobs are being created. So with there's also computer-aided design, which simulates production, which simulate designs before production. So designers are able to use computers to simulate those designs before they go to physical production. So CAD then streamlines design and production processes and reduces waste as designers are allowed to experiment and play around with simulators. Quick response manufacturing has also been in the rise, which is a sourcing strategy that is implemented to manufacture clothing in small batches. It aligns with localization, with manufacturers being more responsive to market trends. It is a shift from sourcing clothing in large quantities, mainly from global manufacturers in China, as I've been saying. And this has resulted in high vertical integration, with some large retailers acquiring manufacturers within the country. And it has resulted in high inventory turnover, which has improved profitability. But at the same time, I should highlight that the value chain is still fragmented. So some of the drivers of technological change, as I've mentioned before, is the shift in sourcing strategies. So retailers previously mainly preferred sourcing clothing in large quantities from Asia. And this has led to the deindustrialization of the South African CTFL industry, which started a long time ago in the 1980s. It was cost effective to hold these large inventories despite significant lead times. So if you think about some of the large retailers, take companies that are owned by TFG, so take Foshin and Sportston, So in the late 2010s, what would happen is that in around January, there'd be large discounts. And then now in the early 2020s, what would happen is that there isn't that large amount of discounts, and that is due to small scale producing clothing in small batches. So, but at the same time, retailers continue to have dual sourcing strategies. Environmental concerns have also driven technological change within the industries, with production of synthetic fibers, for instance, emitting a large amount of greenhouse gas emissions as well as plastic waste. So sustainable production aims to reduces water consumption during textile dyeing. And the process of dyeing textiles is very water intensive. Consumer preferences have also driven technological change within clothing and textiles, with sustainable clothing resulting in low environmental impact, organic textiles, and consumers are also increasingly looking for clothing that is ethically sourced. High-end consumers have also been increasingly looking for clothing that is customized, and with biomechanic clothing. So biomechanic refers to clothing that enhances performance. So for instance, with sportswear, sport people would prefer to have clothing that is light and enhances their performance during their activities. Okay, so some of the technological changes within the value chain. So cotton is increasingly being harvested through mechanical harvesters. Robotic harvesters are still being innovated. So this is research that is ongoing and is not yet fully commercialized. Synthetic fibers are increasingly being produced through nanotechnologies. And there has been a company that has been a spin-off from some research that has been done from Stellenbosch University, which is using nanotechnologies to produce textiles. Yarn is produced through automated processes in blow rooms, cutting processes, and ring spinning processes. In IoT devices embedded in compaction machinery, which assist with the removal of impurities on textiles that are produced. And AI is used to create designs, with CAD allowing for 2 and 3 dimensional simulations, as I've mentioned. CAD is then followed by computer-aided manufacturing, which then directs automated machinery to produce clothing. And some of the tasks that are done, they include cutting as well as assembling textiles into clothing. And then looking at communications between manufacturers and retailers. So QRM is being adopted to shorten production, delivery, as well as order times. It coincides with local production, with some local products becoming more competitive against imports that comes into the country. QRM links the demand side, that is consumer purchases and market trends, to supply sides, planning, production, and supply chains. Then this makes vertically integrated value chains as well as retailers efficient. So also there's real inventory management systems that are used, which are automated and use data analytics to evaluate inventory, consumer purchases, and supply chains. This is also facilitated by RFD tech. So if you take, for instance, if you go to Zara and you buy something and then it's scanned, it's automatically sent to the headquarters in Spain, and it shows that certain product is being bought in the country within a specific location. And then that would be used to analyze if there's an increased demand within the product or not. So distribution warehouses are also being automated, and this includes robotics and conveyor systems, which are used to sort, store, and retrieve products. And as we know, there's been a huge rise in e-commerce. So for instance, you take TFG has Bash, and then Zara has their online store. There's also been a rise in Chinese e-commerce retailers, so Shein, for instance. Okay, so some of the technological changes I'll figure. So what I'll do is I'll present an example of a clothing manufacturing company within the country. So Prestige Clothing was is a subsidiary of TFG, and it was bought in 2012 in order to reduce the dependence on importers and to produce clothing in-house. So traditionally, it would take about 3 months from design into producing a sample to a retailer. And due to local manufacturing, now orders would take about, say, 3 weeks in order to be completed. And QRM processes by TFG have resulted in an increase in large discounts and offload all stock. So this prestige clothing aping factory therefore focuses on high-end clothing and is equipped with automated machinery, including auto cutting machines as well as auto sticking machines. These processes are from patent design. These processes from patent design to cutting are automated. So an electronic planning system was implemented to digitalize the whole production process. This includes digital boards, a process management system that tracks and monitors inventory, and CAD for pattern making as well as grading. So some of the key takeaways from this presentation are that the clothing and textile industries comprises of firms with advanced technologies, but some firms still are using outdated technologies. And the drivers of technological change within the clothing and textile industries are sourcing strategies, environmental concerns, as well as consumer preferences. And automation does mean that manufacturing jobs are being increased, but at the same time, it means that some jobs are being moved into the other end of the value chain. That concludes the presentation. Thank you.
Thanks very much, Lucas. 3 excellent presentations, and I think we've got a strong sense of some of the emerging technologies and what's happening in the South African context. Let me invite Sean to come and give some of his insights as the discussant on all 3 of those papers. Thanks, Sean.
Hi, everybody. Excellent. Well done to the 3 presenters. And I hope you had fun while you wrote this paper and while you did this study, because when you try to track technology and technological change in industries, you will find that technology is everywhere and nowhere. Everybody talks about technology, but we don't often see technological change in our data that's available to us. So I'll quickly just direct some comments to our 3 presenters. So starting with you, Danae, you really gave a good description of these emerging technologies and how they're making inroads into the electrical market. But what I was missing is how is the technologies in the electrical industry changing? For instance, the shift to traction motors, where you don't need a gearbox anymore because you can control the drive strength of a motor. Those are technological changes that's made possible through digital technologies, but it's not entirely digital. Many of you that's recently bought a washing machine in your house would notice that it's a direct drive motor. There's no more pulleys and so on. What I also wondered about is, especially in the electrical industry, but in manufacturing broadly, the industry don't talk about digitalization. They very often use other words like automation. So we need to, when we assess the industry and when we speak to stakeholders or companies, you have to use these words interchangeably. So the one is automation. Companies increasingly talk about simulation, which is what you call digital twinning, but simulation is a unique thing that we see in industry. And a lot of companies also simply talk about process control. The ability to monitor a process, to see where's what, in being able to track and trace a product through the system all the way into a market. Companies use that word, and you and I would say it's digitalization, and they would say, no, it's process control. So we have to pay attention to those things. And possibly if you go back to your data, you will see some things that didn't, jump up and declare itself as a digital technology. A question is also that I also wondered with electrical equipment is also an intermediate good. It feeds into the other industries, and so is electronics, by the way. So you hinted at that, but it's hard to actually see how does a small change in electrical technology enable change in other industries. So if you think back to some years ago when we had so much load shedding, a problem with companies that had a lot of motors on their production line was that they had a real challenge to restart the factory, because when you start up the motor, there's a surge. Those technologies, in the meantime, these technologies have changed so that factories can start up without breaking their power supply. So there's been changes that's subtle, but a lot of companies that couldn't upgrade have been left behind because of that. You gave in your paper an excellent example about how grid monitoring can save money and make maintenance faster. And in that statement, there's two key drivers to why companies would bother with upgrading. Saving cost. Many companies are concerned about increasing a worker safety also, because nowadays if a worker gets injured on duty or a customer gets injured, there's a lot of trouble. Some companies upgrade because they want a distinct advantage. Maybe this is important to just highlight that when we look at a sector, we very often treat all the companies as being very similar. But within each of these sectors, we find that people are positioning themselves on like a chessboard. So companies will use technology to also give themselves a distinctive capability that makes them unique in the landscape. Saul and I often talk, if we go and map an industry, you will literally find one of each of the letters of the alphabet there. You would find one that's using old technology, but very fast, all the way to somebody that's using the latest technology, but not very efficiently, and everything in between. I was expecting to see more about that, because we have an old electrical industry in South Africa and a new. Yes, okay. There's a fourth thing why companies would upgrade. So I've said saving cost, increasing safety, creating a distinct advantage. And the last one is, in many industrial value chains, having the right equipment in place is a prerequisite. It's a requirement. So if you want to supply into the automotive, bless you, if you want to supply into the automotive sector, you have to comply with certain digital integration, traceability, and so on. And so having a barcode on every product for a company would be about process control, and you and I would say it's digital tracing. So to just play with those words. Then Lutando, your presentation, it was great to read your paper. I did several studies on the innovation system in electronics in South Africa many, many years ago. And it was refreshing to just see an update on that. Electronics, we have more than one electronic sector in South Africa. We have a very advanced electronic sector that's supplying into the space, aerospace, and defense sector. So, and the companies like the contract manufacturers that you find in that sector are playing on the global stage, and they have equipment that is made for customization, very high quality, short production run equipment. Then we've got the medical device electronics sector that is somewhere in between, and then the consumer or the the other kinds of electronics. And there are very few players that play in each of those value chains. So that's just an interesting observation. Some years ago, with a big SKA project, we had the challenge that we had to find a contract manufacturer that could make a very particular kind of PC board. And we couldn't find such a manufacturer in South Africa. I'm now not allowed to say the name, but then we found a company that was very deep into the defense sector, and with a small support grant from the Department of Science, that company could be upgraded to make components for the SKA. South Africa is one of the countries that can actually make really advanced electronics circuits for the global industry. It just doesn't show up as a competitive advantage because the industry itself is not so easy to see. Okay, so when you speak to the big international companies, you ask them, why do you have your factory here? They would often say, because we have a contract manufacturer close by, because we have specialized service providers that can maintain X-ray equipment, that can monitor really sophisticated equipment. So the electronic sector, we can't just measure on what they export. We have to measure it also on what it enables. And that's very hard to find in the data. And the last time I counted about 12 contract manufacturers that's available to make more or less any electronic product. And there's probably about a dozen contract manufacturers that only manufacture for the defense, security, and police sectors. And to paraphrase some other very important person to say that said, sensors are now everywhere except in the data. Electronics, sensor technology that measures heat on a conveyor belt or that measures friction on a production line, these things are critical and they would be very hard to detect in the data. And then Lucas, I like how you described the emerging technologies. This slide that you had here right towards the end, it's a very full slide. Okay, we have to find a better way of showing that. But showing practically how technologies are changing is very valuable because people struggle to see technological change. So I think we can build on that slide. But just about the value chain that you presented is at a very high level. And actually, I think as with the other clothing and textiles, we probably have more than one value chain, with maybe the chain driven by the retailers being the most prominent and the most visible, of those. But we also have industrial textiles and other applications of this that's not driven by the retail. A friend of mine the other day said that the prison uniforms, you don't buy them at the retailers, you buy them from the factory. He's an advocate, so that was very funny for him. Okay, so what I also wondered about clothing, a comment that I heard last year from the Clothing and Textile Tech Station that's hosted down at CPUT, is that many of our local brand owners, and I think I can mention K-Way and Woolworths because they're obvious companies, are very sophisticated buyers. So global suppliers are flying here. They don't even do these things via Zoom always. They're coming here because they want to be close to our demanding buyers. So the question that always bugs me is, if we have these demanding buyers, why are we struggling to get our local content up? I asked a CEO of one of our big buyers, I won't say their name now, and he told me that in 4 years, they were not contacted once by a South African clothing manufacturer, but they get contacted every day by companies from Spain, Portugal, and we don't think of these countries as clothing and textile producing nations, but there are people that standing in a line at our retailers, at our buyers, and our South Africans are not in that queue. Why is it like that? Maybe just some overall comments that I want to share from our work, also with working with the Technology Observatory that Saul mentioned, that's hosted at TIPS. In our data, we can find physical technologies because physical technologies are things. And knowing how to maintain a thing is part of the physical technology. Knowing how to integrate a technology into your environment is also a physical technology. But what is often overlooked are the social technologies. The social technologies are those soft, fluffy things of how do we organize ourselves to achieve an objective. So this is much harder to find. You won't find it in a data set, but you can often find it by asking multinational companies, why are you here? And they would say, well, because the Electrotechnical Export Council is so alive. They would point to something in your environment that you won't find by looking only at the data. And those for me are social technologies, our ability to organize ourselves, both within a firm, but also between firms. So you have to pay attention to the physical and the social technologies. For me, a technology is a language. So we have a lot of languages in South Africa. My friends from overseas are always so impressed with our number of official languages. But technology is also a language because it's a way of knowing and you and me agreeing how we can achieve something together. And the challenge is often that we don't look at the technology, what is the word now? The technology architectures. For instance, in the clothing and textile, natural fibers, being able to grow, harvest, and process natural fibers. It's not one technology, it's many technologies that together creates almost something that you could call a natural fiber technology language, because the buyers can communicate with the processors and the processors can communicate with the growers and so on. So to not get distracted by the shiny technologies, the AR and the AI and all of these things, but to also look at the technology languages that we've mastered. So from the metal sector, South Africa can make cast iron castings, we can make ferrous castings, we can make stainless steel castings, and we can make aluminium castings. Those are 4 languages, 4 technology architectures that all sound like they're the same, but they're actually quite distinct. So if you go into the sand foundries, they look very different to what an aluminium foundry looks like that's supplying into the automotive sector. I have mentioned also that in 2 of the studies, you are dealing with a sector that is also an intermediate good into other sectors. So it is important to, we can't always measure these sectors on what they export or what gets sold, because intermediate goods are not always so visible in the data. And the best way to find the intermediate goods is to engage with sophisticated local buyers, because they will be able to tell you, we can only buy this from a company that has these things in place, these kinds of accreditations, these kind of, granularity or precision in their machines. That's how we find these. I want to also make a last comment about the word technological change. Saul and I co-authored a paper many years ago on technological change. And technological change is a big word. It's not where just one technology is changing. It's where we get a feeling that a whole architecture is busy changing. And so the question is, where is the architecture of technology in your sector changing? Energy efficiency brought together, enabled a lot of change in South Africa. But what is currently forcing companies to invest their money to upgrade their process, to make changes? I didn't find that in the paper. I don't think AR is coming in and disrupting the industry. But what is it? What is it that is making companies say we have to raise more funds, or we have to use some of our accumulated funds to grow our business? I couldn't, for me, that's a driver. I really looked for that and I couldn't see that. A key word is the word disruption. So if we are all competitors and Lucas gets a better way of doing something, it might be very uncomfortable for me and maybe even painful, possibly even slightly embarrassing, definitely an inconvenience. But disruptions come from innovations in other industries. Because a disruption is when none of us saw this thing coming and suddenly it's standing with its suitcases on your doorstep. Does it make sense? Within an industry, there's rivalry and there's typically some leakage of information. So you have an idea that one of your competitors is upgrading their process, and you know you're going to have to make a change. So we can say that within an industry, within a sector, there's changes that are predictable, and some suppliers or some companies will be able to tell you in 2 years we're going to have to make that change. We can see it coming. Disruption is when technology gets developed in another industry. It starts off very ineffective over there, very energy, very clumsy. And then over time, because it's refined over there, it suddenly becomes viable in our industry. That is a disruption, because suddenly I have to make changes, but I don't have the equipment suppliers. I don't have the specialists. I maybe don't have the competencies inside my company to make that change. So just to play with that, to try and figure out what is it that is placing a demand on our electronics sector. Where is that coming from? Maybe a very last comment that is also useful to ask industry. Saul and I, we've tried to use this once before with a study we did for the Meseta, and it was quite difficult, but to look at competencies. For policymakers, understanding how does a new technology place a demand on a company's current competencies? Does it require new competencies, so they have to add the kind of people that they've never employed before? For instance, electronic contract manufacturers that has to do non-destructive testing they need to operate the X-ray machine. Electronics companies didn't have to appoint these kind of people in the past. Now they have to. So there's a new competence requirement. Or does this new technology destroy existing competencies? I think, Lucas, you said that the companies are automating, but the staff are being rotated into other areas in the company. Where are these competencies being destroyed? And then a third thing is, where do we need to enhance competencies? Where do we have to invest in upgrading people's skills so that they can use new technologies? So there you have a little triangle with new competencies, competence destroying technologies, and competence enhancing technologies. What we found, and I don't know if it was last year, Saul, when you took the port group to the contract manufacturer, where they told us, as much as they automate, they don't fire staff because they're desperate. They're holding on to their staff. So they're planning their upgrading process, also already thinking about how can I redeploy or reskill my people. And this is something that we don't often hear enough in our policy dialogue. The assumption the whole time is automation destroys jobs. And we actually have very little evidence in South Africa whether this statement is true or false. Anecdotally, for me, it seems like automation creates jobs, but I'm not an economist. That's what you guys have to figure out. But we need good data on that, because when we talk about improving competitiveness, improving automation, and improving competitiveness, other people hear us saying, get rid of workers, get rid of local content, and so on. So we have to, as policy advisors, we have to be able to show that the technological change is resulting in these changes within the firms. Okay, and I'm going to conclude with that remark, but just to say that we have a whole collection of papers on the TIPS website under a project that is called the Technology Observatory. So you are welcome to go and take a look there at the documents and the papers that we've published. And we are working on making sure that your papers are also listed there so that people can find it. Thank you very much. And you've done a great job.
Thanks very much, Sean. I think it captures some of the key issues and tensions very well, and it gives us, I think the speakers as well, some insights into some strengthening that they can do on their papers and how we can expand some of our thinking in this area. I'm going to open up to questions or comments from the floor and online. Let me start in the room. We do have a roving mic and a rover who's going to bring the mic to you. So if you want to raise your hand, is that a hand? Björn from if you want to introduce yourself, and then.
Thank you, Saul, and thank you to the participants. I'm Björn Gerrits from DSTI. I enjoyed the presentations. I was thinking about maybe a question on new technologies. You know, when are they new, and how do you bring in the kind of the hype cycle, and how do you classify that in terms of a framework? You know, additive manufacturing, we've been sponsoring it for 20 years. Is it still new? You know, and the Gartner hype cycle. So that's just one comment. I appreciated Lucas's change analysis at the product level, but also at the systems level. And I think that's probably what I missed in the manufacturing or the electrical motors was it was almost at the component level or at the part level, not really at the systems level. How do we, what are the, let's say, the different cloud systems for health usage monitoring and the lock-in different supplier networks in terms of usage and support and warranties. So that's maybe something to consider. And then I've got a difficult maybe question to discuss, Saul. And that's, I think we're talking technological change, but also economy and let's call it engineering then, or technical change. So, bearing on Sean's experience on technological change, do you almost need to be a seasoned technological change expert to be able to analyze technological change in industries? In Sean's words, technology is a language. So do you have to first become able to speak the, let's call it the additive manufacturing language before you can identify technological change? I don't know. It's an open question to me. Because there's an engineering perspective on change, there's an economics perspectives on change, and then the systems perspective from sort of Sean's perspective. And how do we really integrate that for an optimal answer? Because they're all kind of part of this. Thank you. That's my inputs.
Thank you, Johan. Any other questions or comments in the room? Not now. Okay. Online, I do see one question that's come through to me. I think the first one is, what would be the technological developments for the end of life management? I think we've seen in many sectors the extended producer responsibility, which tries to cover that, but how do we think about what happens with our vehicles, our e-waste, our textiles, our clothing, and that extends into many other sectors. So I think important question, because often we sit here being the receiver of other people's end-of-life products. And we've had to actively ban some of these products from coming in because they get dumped into our economy. But how do we think about it in our own context, and how does that look linked to some of the technological innovations that have come up? So also from our own experience, we visited MinTech, one of the science councils, and they're doing very innovative work on recycling e-waste, because there's a lot of valuable minerals in there. And how do we think about, extracting that viably? And that's the key question for future use in other industries. So if the presenters can think about that. Another question online is just the thinking about the opportunity for economic diversification, and can we also then move to some of these more complex manufacturing spaces? So in the past, I think we sometimes, and I think it comes through strongly in the clothing and textile paper, where we were compromised because we didn't have the economies of scale. But with the new technologies, does that allow us, and that's what the question is asking around, can we become competitive in these complex manufacturing spaces, because we can get in the technologies and we can become competitive that way. So I think for all of the presenters, if you can think about some of your responses to that. Let me take those questions for now. If there are other questions online, you can either put it in the chat and I'll get it, or you can ask to be unmuted. I think we can do that. But otherwise, let's go with some responses. And Sean, even as though you thought you were not going to be answering questions as a discussant, what one has been thrown to you. It probably is easier, I think, if you come up here and respond. So we can take it in order of presenters. So let's start with Danae.
Sure. Thanks everybody for the questions. I must admit, I don't have a response for many of them right now, but we are working on quarterly updates for the manufacturing subsectors work. And I think I would be able to unpack a lot of them in the next quarter. With regard to new technologies, or when they're new and when they aren't new, I do understand that additive manufacturing is something that's been with us for a while. I did go with it because of a lot of the, let's say, scientific research, the journals talking about its application in electrical equipment are quite new, ranging from like the late 2010s into as recent as 2024, 2025. So that's sort of how it made its way into the report. Regarding technological developments for the end of life stage, there is a paper on sustainability in the electrical equipment industry, which is yet to be published. It just came back from our editor. That does cover some things like the EPR and a few other approaches to managing electrical equipment at the end of life stage. Regarding economic diversification, again, I would have to do a little bit more research into that. Sure. Thanks.
Okay, thank you for the questions. Yeah, similar to Dene, I think, this actually requires further research. But in my attempt, when it comes to how do you classify new technology, I think, okay, based on the research, when we're doing the paper on technological changes, it was actually difficult to establish if this is a new technology or old technology. But when it comes to, for example, advanced packaging, I actually found a paper that describes in terms of the timelines when it comes to when were these technologies applied or came into the market. So, for example, with the wafer level packaging, with the I think it's a fan out, for example, those are sort of the older ones, and the more advanced ones were in the post-2010 period at the global level, where you see the 2.5D stacking and the 3D stacking that came into use in the industries at a global level. So when it comes to the end of life stage technologies that are there, or the policies that enable the sort of the end of life stage of the products, I recently did an update on the sector, of which I found that I think it's the e-waste policy. I just forgot what it's called. So please assist. So the bill was sent out by the DFFE last year for comments, and of which I think in August it was then implemented. So that involves the electronic waste policy, like it includes batteries and other electronic products. So with no, I'm not going to attend to the economic diversity question. I think it needs further research. Thank you.
Okay. Yeah. So I have to admit that the presentation as well as the paper has a high-level overview of technological change as well as processes. So we weren't able to look at particular say product within clothing and textiles and detail them. In terms of value chains, there are value chains within value chains. So textiles is its own value chain, clothing is its own value chain, but at the same time, there are value chains within that value chain. So in terms of local brands and being sophisticated buyers, so the issue there is that local manufacturers are not competitive in terms of producing certain products, which has resulted in local brands importing products from other countries. I mentioned that TFG bought Prestige and they're manufacturing clothing for sports in the Epping factory in the Western Cape. At the same time, TFG still imports clothing from Mauritius as well as other countries into the country. So there are still limitations within production processes here in the country. And in terms of cotton production, South Africa is not rich in producing cotton. So what happens there is that textile manufacturers would then import cotton into the country because local production doesn't meet local demand. In terms of limitations to increasing local content, I sort of mentioned the lack of competitiveness. So the industry is not competitive in terms of pricing. In terms of competence, so TFG, the example I've mentioned of Prestige, it has been doing a good job in terms of moving skills, the competencies that are within certain aspects of the production process into the other production process. So for instance, if a sewer is replaced by a swim port, they're being moved into the other end of the value chain within the company, and then they are able to do a certain other task. So it's not that they get rid of them; they still retain the staff and retain those competences at the same time. But also in terms of what I should mention about manufacturing jobs being lost and where they're being moved. So manufacturing jobs would be lost within manufacturing, and what would happen is that logistics logistics jobs would then come to the fore. So for instance, imports from Shein would come in, and there would be jobs within that value chain that would come to the fore. And in terms of social technologies, within clothing and textiles, you can think of clusters. So in clusters, what they would do is that they would have seminars, and they would be able to share ideas as well as the operation processes. So social technology does exist within the clothing and textile industries. And in terms of disruption, you mentioned that innovation would come from one industry and then would be used in other industries. And we see that in terms of nanotechnologies within South Africa. As I've mentioned, Stellenbosch University started with researching on nanotechnologies, and they were able to then develop a company that is able to produce nanotextiles. And in terms of life management, yeah, I have to admit that South Africa has to improve in terms of managing waste. There was a study which was done in the Western Cape within 6 municipalities, and it showed that within the waste field, 6.4% were textiles. So there is a lack of management of used textiles. So what the EU does is that they are able to separate waste. So there will be bins for textile waste, there will be bins for bottles and other different materials. And in that instance, they are able to manage the life cycle of textiles. Thank you.
I would comment, starting from the back, going to the front. The end of life is an interesting example. I don't know if you can recall, a few months ago, Woolworths announced that they'll be buying back jeans material because they wanted to run a pilot to reuse jeans. The funny thing is that then a lot of smaller companies realized, hey, this old pants has value. But there are experiments going on to see now how can a retailer buy back clothing. But the challenge with jeans is the young people like it when it's torn. So I'm not exactly sure how this business model would work. About diversification, what is amazing for me is in every one of our industries, we find a small group of leading companies that have also service providers and specialists that make it possible for them to perform locally. We actually have the basis for diversification in our country. It's just like we're not getting companies to invest and expand. This is something that I've been, pondering for a long time. Why is it that we go and visit these companies and they tell us we have state-of-the-art production facilities, but they run one shift a day? People would say to us, we are completely overrun with orders, but they will not introduce a second shift. So that's where you economists have to go and dig. For me, this doesn't always make sense. Because you would expect industry to be able to, when there seems like there's a boom in demand, you would expect industry to step up, and it just doesn't seem to be happening. Just in the last few weeks, speaking to companies that are preparing their Black Friday sales now in October. Can you believe it's that time of the year? If you go to Pick n Pay, they're singing carols over the speakers. And he said their biggest fear is that the Black Friday sales takes out of their volume things that they need for the Christmas sales. And it's like, but you've known Black Friday is coming for 10 months. And he said, yes, it's the difficulty of securing supply from South African providers is really, really hard. So a successful Black Friday immediately creates challenges then for the Christmas season. About Buen's question about when is something no longer new? Buen, you know how to trigger me. This is such a great question because in all the so-called 4IR technology, South Africa had at least one champion, with additive manufacturing being an example. I think what is new moves. 20 years ago, being able to create the prototype with a 3D printer was new. Then with the RLAC project, being able to validate a component for aircraft on a 3D printer was new. What we haven't yet seen, Bjorn, is 3D printers in production lines. That is the next new. So I think new is shifting. So we can go through the technologies like that one by one. We've had a AR center at the CSIR since, before we had proper screens. So AR isn't new, but being able to use AR on a production line to fault find why something, why a green light isn't green, we're not seeing that. We are seeing in more and more factories, workers walking around with iPads. We are seeing these technologies going on, but I think the boundary of new is constantly busy moving, and we have to keep up with that. Sometimes we pretend and we try to show these technologies are emerging, but in many sectors, these technologies are already old news. If you just think the most visible form of Internet of Things that you see every day of your life, these little checkers motorbikes going everywhere, 60/60, where you can track on your phone where your delivery is. You can start baking the eggs, the toast is on the way. This is IoT technology, and it's become an everyday phenomenon. The private sector don't take us serious when we treat these things as completely new. What is amazing about our logistics sector in South Africa is it has embraced this technology so that even the consumer can benefit through the rapid ordering system and knowing when to go and stand outside to collect your delivery. It's quite interesting to hear that Amazon, for instance, held back launching in South Africa until the final mile of delivery costs had come down. So they've been ready to invest in South Africa for a long time, but they had to have that final hurdle in place. And it's been in place now for 3 or 4 years. So I expect the boundary of what is new to shift again. Just something about new, and I must now get this quote wrong. We always tend to overestimate the impact of new technologies in the short term and underestimate the effect of these technologies in the long term. So 5, 6 years ago, when everybody was going on about AI and that, the people were not ready. And our challenge now, again, as policy advisors, is now the technology has changed. Our companies should be playing with these technologies by now. They shouldn't be new, like Bjorn said. There should be people in a company that can already figure out how to integrate these things into products or processes. But the industry doesn't take us serious when we constantly talk about these things as new, because I agree with Bjorn, a lot of these things are actually established already, but it's not widely known, Bjorn. That's still our challenge. A last comment just on being able to speak language of technology. I think this is maybe something that we should ponder, because for every technology that you can imagine, between us in this room, we'll be able to find one firm that's using it. But you don't build a diverse and complex economy just on one firm here and one firm there. So the question is, how do we build, I don't want to say scale, because I think South Africa's future is probably going to be in small production runs. But how do we build sufficient volume so that we can attract more investment? For me, a big indicator that we have some of what is needed is when you have multinational companies still putting down design centers in South Africa, still putting down manufacturing plants in South Africa. That for me is a good indicator. When the multinationals are only represented by a warehouse or logistics center, that freaks me out a little bit. But I'm going to stop with that. Saul, was there another question that you thought I should have answered?
That's fine. We can bring you back if we need to.
Okay, yeah, I'm not going to.
Thanks. So we've got a couple of comments as well. But also, I think from my side, just framing the project. Why did we do this as tips? Why did we want to think about technological change in industry? And part of it was to say there's a lot of new technologies, but not brand new. And so part of the brief to the team, and I was doing the briefing, so I am to blame for this, was to look at technologies that are proven and work. So, and to avoid the novel ones. So to Sean's point, the hype about the new that could overpromise great changes because it isn't proven yet. So our focus really was what is new that is proven that our industry could use or are using. So, I mean, you could see in the presentation to start, what is globally the innovation? What are we doing locally? And there's a gap. I mean, we can see, I mean, it's you know, we didn't have the chance to present the whole paper, but there's a gap. There's a gap in what we see happening at the global stage and what's happening at the local stage. And some of the other work that we're doing, and I think Bevan, you may be aware of it, is how do we bridge that gap? You know, so why aren't some of our firms adopting proven technology or innovations or processes that will enhance their production processes? Why aren't they making that investment? Other firms in the industry are, but others aren't. Something that I always remember, it was a few years back, and in a pre-COVID world, so a long time ago, was speaking to the CEO of it was a listed company, who was saying he's visited his production plant, and so he was relatively new in that company, and this technology that's 60 years old, okay? And, you know, some of it, I mean, it's functional, it works, but it does create a problem in efficiencies, in waste. So you end up, you know, if it's in a manufacturing firm that's making metal products, there's waste that isn't being effectively used. And we can see it in the CTFL work, where a big innovation has been, how do we reduce the clothing waste? In the metal space, that is still a big challenge, where we're not always effective in using the latest technologies to minimize the waste, because that waste has an expense, that scrap has an expense. And if you can cut down on it, you don't have the waste that's expensive. And so we can see some of the drivers, and I think Danae put up, what are the drivers of change, of technological change, and those are important things. Let me then jump to some of the comments that we've received online. So there are lots of thank yous for interesting presentations. Some of the other comments are, you know, unpacking the value chain is important because, you know, once we do that, we can deal with some of the blind spots and limitations of a high-level value chain. So I think, you know, as we go deeper into it, and in answering Bevan's other question, we're not engineering experts. We're coming at this from an economic lens, but trying to understand the landscape means we do take a value chain approach. We do look at what the other people are doing, the engineers are doing, and the technology experts are doing. But I wouldn't send our team to go and advise a firm on technology. We're doing the high-level overview, whetting people's appetite. They need to do their own exploration about what works for their company. But it gives insights, excuse me, gives insights into what's possible in a world of possibilities that are out there. The other comments that have been raised are where is it? Okay, the importance of making a distinction between automation, process control, and digitalisation. And I think Sean does raise the differences, and that, you know, some of these things can be automated, but can't always be digitized. And then another comment is, it would be interesting to see a benchmarking comparison, looking at technological change in our sectors with other comparator countries. So, you know, if we're assessing our competitiveness, if we're looking at other countries, what does that mean in terms of their adoption of technology, but also, I don't know if the information is available in other countries, but to try and get that sense of what we're doing differently. There is a last question, and it's specific to clothing and textile. Okay, to what extent does integration into global value chains drive technological change in our sectors? Clothing and textiles are still considered labor intensive in South Africa, and to what extent does technological change that, and a change in the job intensity? Lutando, I don't know if you can even respond.
Okay, so clothing in Texas is still labor intensive. So if you look at South Africa, the value chain is mainly, even with employment, it's concentrated in wearing apparel. So that includes the sewing and putting together of clothing. So that indicates that it still continues to be labor intensive. And integration into global value chains means that some of the jobs within the country or production processes are being conducted elsewhere and not in the country. So in that case, it affects mainly textiles, and it doesn't affect clothing production per se.
Okay, thanks. We've come to the end of the questions online. So before we close, I wanted to give each of the presenters and our discussant just a minute to wrap up and give their concluding remarks, just from the whole discussion and some of the comments that have raised, and also some of the feedback that you've received. So I'm going to ask you each to do that, including Sean, and then I'll do a short closing.
Thanks to the members of the audience for their insightful comments and the questions. I do apologize for not being able to answer them right off the bat. But like I said, there will be quarterly updates, and I'll be sure to pay attention to some of the aspects that were raised today. Thank you.
Yeah, thanks, Sean, for your insight, and thanks to other colleagues for their questions. Yeah, in terms of slide 3, you were correct about improving how it was presented and elaborating the value chain in that instance. So that's definitely something I look into doing. Thanks.
Okay, thank you. Thank you, Sean. Your feedback was quite yeah, your feedback was quite insightful in terms of, the other experts where South Africa does operate in terms of production. Also, overall, with the comments and other questions, my key takeaway was that there needs to be further engagement with the stakeholders in terms of firms, for example, in order to deeply understand the landscape of the electronics industry. Thank you.
Thank you. From my side.
Do you want to come stand?
Must I stand somewhere?
So that the camera can see you.
Oh, okay, good. Where must I look?
There, yeah, you can. There's the camera.
One eye on each camera. Okay, so it was really great to see these presentations and to read your papers. And I could also see the frustration that a lot of technological change we can't see in the data. So we have to think about that. It's something that we've been thinking about for a long time, because we would have to find other indicators. What I just want you to be mindful about is not to get distracted by the shiny things that announces itself, and to think of how changes in our own economy can drive technological upgrading. Think of the countdown to day 0 in Cape Town some years ago. Can you remember that? It was a very big thing for industry. A lot of changes in manufacturers were driven by a fear that they would run out of water. And then they used the technologies that you presented to manage their processes better. So to not always expect the change to come from a well-announced category, but to pay attention to what is driving, what is making it, let me use the word incentive. What is providing the incentive for an industry to invest its money? Or do they have an incentive to keep their money and just keep the old equipment? But something that Saul said that we also often amused by, and I think your example of the company using 60-year-old technology, we also have examples of companies using old technology and being globally competitive because they really understand the science and the technology of their process. So we mustn't always equate newness with competitive. Okay, so just that's an outlier comment, because for most companies, new equipment in theory should result in more competitive production, but it doesn't always translate to that. I've literally visited robotized, automated companies that still cannot compete. And you can't tell me it's because of labor cost. It's for other factors. So we just have to be careful of those. I think I ended at that. I'm looking forward to engaging with the researchers and the rest of the TIPS team on figuring out how can we bring this technology perspective into our studies, and what we can do where important things are not captured in the data. So well done. Thank you for organizing this event.
Thanks. Okay, and then closing from my side, I mean, technological change is upon us. I don't think we can avoid it. So in undertaking these studies, we've approached it from an industry perspective. So each of the researchers has looked at their industry, and then in addition to doing the overview paper, as I said in the beginning, we've done the paper on sustainable development, international trade and technological change with updates quarterly. So that focus on trying to understand the change from an industry perspective is very important, and understanding the value chain and what's happening in that industry is incredibly useful. What we can't avoid is continually scanning the environment for the change. And that's why we've embarked on this project, is so that we better understand the environment in which we're operating. As firms in an industry, or industry associations, or people who are working with industry, it's really useful to go and say, okay, what's going on in the world? Where are we? How's the change happening? And we've hoped that through these series of papers, we're starting to provide those insights and adding value. So thank you to the researchers and the presentations you made today, and helping us to think through what are the changes in the global space? What are the changes we're seeing in the country? There are many drivers of these changes, and we've heard some of them. There are other drivers that are happening all the time. There's a geopolitical war at this stage that is also driving other changes that we need to think about. And so for industry people and for government people who are supporting those industries or engaging with those industries, this kind of thinking takes us forward, and that's what we've hoped to achieve. So thank you to our presenters, for everyone who's joined online and in the room, and have a good afternoon.